Hi, geometry. So we're in activity 8 now. So we're going to start talking about parallel and perpendicular lines. So today in particular, we're talking about their slopes. So we're going to make some conjectures about slopes of parallel and perpendicular lines, and then use slopes to determine if something is parallel, perpendicular, or neither. So open up your books to page 89, and let's go ahead and get started. So we're going to be looking at this ramp here. Okay, so it says the new ramp at a local skate park is shown above. While the image of the ramp may conjure thoughts of kickflips, nollies, and nose grinds, there are mathematical forces at work here as well. So let's look at this. We're going to fill in this little chart. But try really quick, describe two parts of the ramp that appear to be parallel, two parts of the ramp that appear to be perpendicular, and some that are neither parallel or perpendicular. So kind of take a second there and use the picture, kind of come up with your own answers to go inside that box there. Okay, so when I'm looking at parallel, and you may have chosen different options than me, but I'm maybe going to go with lines BD and EF. Those look parallel to me. They look like they just run side by side, right? So that's kind of what I put in here. Lines that maybe look perpendicular would maybe be this line here, BC, and the bottom line, AD. That's what I picked. You could have picked something else, but that's kind of what I chose. So I said AD is perpendicular to BC. And I said those look to be parallel. And then two parts that look like they're neither. Let's see. Maybe, okay. AB and BD, those just kind of are adjacent. They're next to each other, but there's nothing really special about them. So I'm going to say AB and BD. Okay. So as we get into this section, we're going to be really looking at parallel lines and their slopes. So if you recall how to find a slope from Algebra 1, you can use the slope formula there, the change in the y's over the change in the x's. Or if you have a visual picture, it's just easier to kind of do the rise over run, right? By just counting how the graph changes, rise over run. So let's look at this picture here. We have lots of points. So it says the diagram above shows a cross section of the skate ramp, and it's railing transposed on a coordinate grid. So they took that ramp and they kind of put it on a grid here. Now I just want to point out a couple of typos. Okay, instead of WV, we're going to use YW. And instead of VU, we're going to use YU. So your book has a little bit of typos there. But let's calculate the slopes of those lines. So we have YW. So let's look here. So here's Y. Here's W. So if I do that rise over run, it looks like it goes up 1 and right 3. So remember, we use M for slope. So it looks like the slope of that line was rise over run, 1 over 3. So now if I find the slope of my other line, YU, looks like that rise here, we go up 3 in a run of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's see, the slope of YU is 3 over 9, but we know we can reduce that fraction to 1 over 3, right? So in question 2, then, they want us to explain why the slopes of YW and YU are equivalent to the slope of XT. Now take a second there and find the slope of, actually we're not going to use XT, we're going to use YT, another little typo. Okay, but if you find the slope of that one, you should get that it is 412, which again reduces to a third. So if we look at all those slopes, okay, they're all equivalent. They're all the same fraction when they're simplified, 1/3, 1/3, and 1/3. Okay, and if we look at those lines, we're all kind of the same line, right? Let me just kind of color code this. So this line compared to the blue line compared to YT, which is that line. So we can kind of get a picture of what they're trying to get us to see here. But I want you guys to kind of take a minute and do number 4. So we'll find the slopes of those segments that they have listed there. So go ahead and take a second and do that. So just do the rise over run on that picture above. Okay, so here is what I got, okay, from the book. So AB was 1/3, XT was 1/3, WG was -3, and so was TG. and then AD was 0. So what we're going to do is we're going to take these slopes and we're going to put them in this chart next on the next page on 91. Okay. So if we look at AB and XT, those are ones we just found on the previous page. Okay. But those slopes were 1/3 and 1/3. And if I look at their picture on the graph, AB, okay, let's see, where's AB? AB is here, and XT is here. What can we concur about those lines? Well, those are running in the same direction. They're not crossing each other. So that's why we would kind of describe those as parallel lines. Okay, so let's look now at W, G, and TJ. If you look at those lines on the grid, what can you think about them? Are they parallel, perpendicular, or neither? And those ones also look like they run parallel, and we calculated their slopes already. They were both -3. Okay, so now let's look at XT and WG. So look at those lines, XT, WG on your picture. So let's see, XT, going back and forth a lot today. So XT is this line here, and WG, this line here. What can we kind of think about that picture? What do those lines look like? They are? Those lines look perpendicular to me. And if we look at the slopes that we found for those, they were 1/3 and -3. Okay, so I'm just going to unveil the rest of this chart here. So XT and JT, those were also perpendicular. AB, AD, WG, and AD, those were neither. So let's look at the lines that were parallel. So we said the first two boxes were parallel. So make a conjecture then about the slopes of parallel lines. So what do you think if we have two lines and we compare their slopes? If they're parallel, what do we know about those slopes? Well, parallel lines have the same slope. So they have the same rate of change on the graph. Their rise over run is the same pattern. So that's why they run side by side, because they're never going to intersect. What about the perpendicular lines? So those lines that were all perpendicular, comparing their slopes, what would you say about those slopes of the perpendicular lines? So we would call those opposite reciprocals. Reciprocal, remember, is the opposite fraction. So 3/1 and 1/3. That's a reciprocal. The fractions are flipped. And they're opposite, meaning they have opposite signs. One's positive and one is negative. Okay. And then segments that are neither, they have no relationship between the slopes. Okay, there's nothing special about them. So just remember, same slope implies parallel, and opposite reciprocals implies that they are perpendicular. This is the big takeaway from today's lesson. That's what you kind of want to know for slopes of parallel lines moving forward. So same slope parallel, opposite reciprocals, that is perpendicular. So let's look at these questions here. Let's check number 9. So number 9 says the line JK has a slope of 2/5. MN has a slope of 5/2. Are these parallel, perpendicular, or neither? So compare that to that chart on top. Would you say that these two slopes give us parallel lines, perpendicular, or neither? So the answer here is neither. So even though they are reciprocals, 2/5 and 5/2, they're reciprocals, they're missing that other key component, which is that they also have to be opposite signs. So in order to be perpendicular, one of those would have to be negative. Okay, one's always negative, one's positive. All right, let's look at 10. We're going to do 10, 12, and 14 here. So number 10 says AB is it parallel to DC? So let's look at our graph. So is AB parallel to DC? So what you'd want to do there, and I kind of just covered up the points, but check those slopes, and if they're parallel, remember they have to have the same slope. So are these lines parallel? Yes or no? Okay, the answer here is no. If I look at my slopes for AB, let's see, it rises 1, 2. So that's 2 over, let's see, 1, 2, 3, 2/3. The slope for DC, let's see, it goes up 1, 2, 3, and a run of 1, 2, 3. 3/3 would give me a slope of 1. So see how they're different slopes? They are not parallel then. Okay, next let's look at DC. They want to know, is DC perpendicular to AD? So here's AD. Is DC perpendicular? So again, use those points, compare the slopes, and remember, perpendicular lines have to be opposite reciprocals. Okay, so the answer there was yes. DC, we already found that they had a slope of 1. Right, 1, 2, 3, 1, 2, 3. Yep, and then AD has a slope of 1, 2. That has a slope of -1. So 1 and -1 are opposite reciprocals. Okay, last one. It says the angle RST, okay, is a right angle. If RS has a slope of 3, what must the slope of ST be? So RST, if that's a right angle, what do you know about the lines that make up something that is a right angle? Okay. This answer should be that they're opposite reciprocals. If those lines are perpendicular, okay, they form a right angle. So in this case, if it's a right angle, that implies we have perpendicular lines. So in that case, they needed to be opposite reciprocals. So +3, -1/3. Okay, so that is our first lesson on slopes of parallel and perpendicular lines. Again, the main topic today that you want to kind of just remember is this relationship between the slopes and their classification. Same slope, parallel, opposite reciprocals, perpendicular. Anything else would just be neither. There's no relationship.